Hello students, welcome to Study It Out. This question is from Physics, chapter Nuclei. In the question, we have to obtain the binary energy of the nucleus Fe and bismuth in units of MeV from the following data. So in the question, we have already given the experimental value of the mass of iron and the experimental value of the mass of bismuth. And separately, we have to find the binding energy for Fe and Pi. So we represent this as m dash for Fe and this is the m dash for Bi, and both are the experimental value. So let's solve this question. So in the first part, we will find the binding energy for Fe. So to find the binding energy, the formula is Eb is equal to delta m into C square. Eb represents binding energy, delta m is the mass defect, and C is the speed of light. Its value is 3 into 10 to the power 8 meter per second. Now what is mass defect and how to find it? So if we have iron, its atomic mass is 56. We represent it as A. We represent it as Z. If we have to find the mass defect, we need to find the theoretical mass value and experimental mass value. This M represents theoretical mass and M dash is the experimental mass. So how to find the theoretical mass? Experimental, we already know that it's given in the question. Here is the experimental value. But we have to find the theoretical value. So theoretical value, if we have to find, it is equal to the number of proton into mass of one proton plus number of neutron into mass of one neutron. So mass of proton value is 1.007825 U and mass of neutron is 1.008665. Generally it is given in the question, or better if you keep in mind. So we have to find the number of protons and number of neutrons. So to find the number of protons and number of neutrons, we are going to use the atomic number and atomic mass relation. So we know that A is equal to atomic mass is equal to number of protons plus number of neutrons. And we also know that atomic number is equal to number of proton. So in the question, Z value is given as 26. So number of proton is equal to 26. And we have to find the number of neutron. It's equal to A minus NP. A is how much? 56. So 56 minus 26, it's equal to 30. So we can say that number of proton is equal to 26 and number of neutrons is equal to 30. So let's substitute these values. So M is equal to 26 into 1.007825, 30 into 1.008665. So M is equal to 26.20345 U plus 30.25995. So further by adding, it is 56.4634 U. So this is the theoretical value. And we have experimental value. So based on that, we can write delta M is equal to 56.4634. That's the theoretical value minus experimental value is given as 55.934939 U. So this is the given value. So delta M is equal to 0.528461 U. So this is our mass defect value. Now, if we have to find the binding energy, we know that we have to use delta M into Cs square formula. So there is a one conversion. The conversion is 1U is equal to 931.5 MeV by Cs square. So if we change this U to this value, can we write it as EB is equal to 0.528461 into U is changed to 931.5 MeV by Cs square into Cs square. So here you see this Cs square gets cancelled. So we can say that EB is equal to 492.2614215 MeV. So this is the answer for the first part of the question. In the second part, we have to do the same thing, but here we are using the bismuth. But the pattern is exactly same. In the second part, we are going to find binding energy for Bi. Its atomic mass is 209, atomic number is 83. So first we find the number of neutrons and protons. So A is equal to 209 and Z is equal to 83. So A is equal to Np plus Nn and Z is equal to number of protons. So Z value is how much here? 83. So we substitute it. Number of protons is equal to 83. Now we have to find the number of neutrons equal to A minus Np. A is 209 and Np is 83. So number of neutron is equal to 126. So now we have number of protons and number of neutrons. Now we have to find the theoretical mass. So M is equal to Mp into Np plus Mn into Nn and substitute the value. Mass of proton is 1.007825 into number of proton is 83 plus 1.0086665 into 126 U. So M is equal to 83.649475 plus 127.09179. So M is equal to 210.741265. So this is the theoretical mass, we got it. Now experimental mass is given in the question as 208.980388. This is already given in the question. So mass defect is our delta M. It's equal to theoretical mass minus experimental mass. So if we subtract both the values 210.741265 minus 208.980388. So after solving, it's equal to delta M is equal to 1.760877 U. So this is our mass defect. And again we use the same relation. 1 U is equal to 931.5 MeV by Cs square. So here EB, this is our binding energy. We have to find the binding energy. So EB is equal to delta M into Cs square. So let's substitute the value. Delta M is 1.760877. This U will change to this relation 931.5 MeV by Cs square. So 931.5 MeV by Cs square into Cs square. So these two Cs square gets cancelled. So EB is equal to 1640.2569 MeV. So this is the answer for the second part of the question. And previously we got it here. This is the answer for the first part of the question. So if you have any doubt, any confusion in this question, you can mention it in the comment box. I will try to resolve it. Thank you so much.